In this tutorial, I will explain how to optimize your application for the best performance. So you have developed your application and it looks great and has all the functionality, but you are not very happy with how it performs. There are operations there that are too slow, or it cannot be used by more than a handful of users at a time, or both. What do? How do you address the performance issues? Usually performance problems are down to the following issues. Business rules are not optimized. Queries are not optimized. A variable is not configured properly. The application is not optimized for concurrent users. The system reached its performance limit and needs to be scaled up. Let's look at each of these areas in more detail. We'll start with business rules. Business rules are executed throughout your application, and if you're not careful, you can really slow down certain areas of the application. Performance problems with business rules are usually down to the following areas. So-called cross-reference rules are executed unnecessarily. Rules are executed unnecessarily and multiple times. Expensive rules are executed too often. Examples of expensive rules are aggregate operations and find action. Let's look at the so-called cross-reference rules first. They are difficult to explain without an example, so let's have a look at one. Here I have a small application which manages purchase orders. Each order consists of one or more line items. Each line item has quantity and price. This is all very straightforward. So we have the corresponding purchase order business object, which has a multiple reference to the line item object. The line item object has quantity and price, and it has the calculated total attribute and a rule that calculates this total by multiplying quantity and price. The purchase order object also has the total attribute and a rule that calculates this total by summing up the totals of all line items that belong to this order. In addition, the purchase order has the type attribute, which can be A or B. This is just for the illustration purposes. And the line item object has a rule which calculates the initial price of the item based on the type of the purchase order. If the type is A, then the initial price is 50. So once again, this is all for the illustration purposes. Let's turn on the rule log create an order and see how rules are executed. So we'll log into the application and let's create a new order. I'll select a type and I will create a couple of new line items. Let's now see what is displayed in the rule log. Here we can see that 2 line items are being created and 1 purchase order. If we look at the rules of the line item, we can see that the total rule is being executed here, which is what we want. But here we can see a line that says executing rules that refer to the line item. These are the cross-reference rules. When an object such as line item is being created or modified, a variable looks not only on rules attached to this object, but also on rules of other objects that refer to this object, line item in our case. We can see here that the rule is the total rule on the purchase order. This makes sense. A new line item is being created, so the rule that calculates the total of the order that consists of line items is affected and gets executed. Let's ignore other rules for now and update the order. Let me just find the order, change its type, and save. Let's look at the rule log now. So here we can see that the purchase order is being updated and the rules of the order are being executed. Since the total rule is unconditional, it is executed here. But now look at the rules that refer to the order here. We can see that AwareIM considers the initial price rule on the line item as the rule that refers to the order. Indeed, there is a dependence on the order here. If the type of the order changes, line item could be changed as well. So AwareIM executes this rule for every line item that belongs to this order. This can be very expensive. Moreover, in this particular case, it is totally unnecessary. We only want to execute this rule when the line item is created and nowhere else. Once the line item is created, we don't care if the type of the order changes later or not. So we do not want AwareIM to consider this rule as a cross-reference rule. To do this, we go to the advanced properties of the rule that AwareIM considers a cross-reference rule. The initial price rule of the line item object in this case. And then we tick the Do Not Check Referred Attributes checkbox here. Let's update the order and see how rules are executed now. So I log in again, find the order, modify it, save, and let's have a look at the rule log again. We can see that the rules of the order are executed as they should, but now there are no cross-reference rules anymore. So if there are areas in the application that are slow and which are executed by users quite often, we need to study the rule log very carefully and see if there are any cross-reference rules there that are executed unnecessarily. Not only that, we should go through every single line in the rule log and make sure that the execution of all rules makes sense and there are no rules that are executed repetitively and or unnecessarily. If there are, we should add conditions to these rules to prevent them from executing unnecessarily. Another issue that can cause problems is execution of aggregate operations. Aggregate operations are operations that involve exists, count, sum, and average expressions, such as, for example, the total rule. Aggregate operations are expensive as far as performance is concerned and should be used with care. If you have a rule that uses aggregate expressions that is executed multiple times, think what you can do to prevent this from happening and only execute the rule when absolutely necessary. Let me show an example. I have modified the initial price of the line item object slightly and removed the isUndefined condition, again only for the illustration purposes. Let's look at the log now and see what happens when a line item is created. Here we can see that the total rule is executed 3 times, once during initialization and twice after the user submits the values. During the first execution, the total gets calculated with the value that the user has entered. But then the price is reassigned by the initial price rule. This triggers second execution of the total rule. And then the new value is calculated during the second execution of the total rule. The total rule just modifies the attribute, so it is not expensive at all. But imagine that the rule was expensive and used aggregate expressions, for example. How can we make sure that the rule is executed once rather than 3 times? First of all, we would need to make sure that the rule is not executed during initialization. So we go to the advanced properties of the rule and select Do Not Use Rule During Initialization radio button. But how do we prevent the rule from executing twice when the item is being created? One technique is to use rule priorities. AwareIM assigns these priorities automatically, but we can assign them manually as well. So if we assign the lower priority to this rule, it will be executed only after all other higher priority rules are executed. By default, AwareIM assigns priority 50 to rules that modify the attribute. So let's assign a smaller priority. Let's have a look at the rule log now. As you can see, the rule is executed only once now. In some cases, you may have a complex algorithm that you implement using business rules and it doesn't perform well. In those rare cases, you may consider writing a Java plugin that would implement the algorithm instead of business rules. A plugin can be significantly faster. Well, that's probably all about business rules. Let's look at the other area that can cause performance problems: queries that use the find action. Whenever AwareIM encounters a find action, either in a business rule, process, or when running an AwareIM query, it translates this find action into the corresponding SQL select statement. Sometimes this is done in the most efficient way possible and cannot be improved. But quite often, the resulting SQL select statement can be optimized if it is written manually, especially when you use complicated find actions, and especially those that use subqueries. So if you find that a particular query takes too long to execute, then try replacing it with a stored procedure. Stored procedures are written using SQL, so you will need to know SQL select statement in order to do this. Once you add a stored procedure to your database, you can execute it from a process using the exec_sp action, or you can replace the find action in an AwareIM query with an exec_sp call. See the user guide for more details. Let's move on to another area that can affect performance: configuration problems. Well, obviously the better machine you have, the better. But you also need to make sure that you allocate adequate memory to your AwareIM server. If you don't, the entire application may struggle. You allocate memory on the AwareIM control panel by clicking on the Settings button. Most of the time, you need to worry about the memory for the AwareIM server. Tomcat should be happy with the 256 MB or 512 MB for most applications. But the amount of the AwareIM server depends very much on the application itself. For many applications, 512 MB will be enough. For other applications, you have to go up to 1 gig, and for some application you may need more than that, in which case you will need to reconfigure AwareIM to use Java 64-bit. How do you know if you have memory problems? Well, if you have a crash one day and you open the output of the AwareIM server here, and you see out-of-memory messages in this window, That's a sure indication that you need to increase the memory for your system. Let's now talk about concurrent users. The question that we are being asked very often is how many concurrent users can a ORM support? Well, the answer is that it depends. It depends on how the application itself is written. A ORM does not impose any limitations on the number of concurrent users, but your application might if you are not careful. Let me explain why. When a user requests an application to do something, save a form, run a process, and so on, a ORM starts a database transaction behind the scenes. This transaction may lock some database tables that it operates on. If a request takes a long time to fulfill, the transaction may stay open and the tables will remain locked, preventing users from performing operations that involve these tables. Therefore, if you need to support many concurrent users, you must make sure that the requests that users send to the system are fulfilled quickly. You should avoid operations that take long time to execute, run big reports, perform data processing using the find action that finds many instances to work on, and so on. You need to find workarounds. For example, rather than running a big report straight away, you may schedule the report to run overnight, or be processed by another server altogether. Using in batches clause in the find action helps as well, because every batch starts a new database transaction. So in other words, as a developer, you need to be smart about your application and make sure that every user request is short and sweet. Of course, at some point, your server may reach its limit as the number of users continues to grow. In this case, you need to scale your system up and add another server. Doing this is relatively simple. You need to install a ORM on another server, get this server to connect to the same database that the main server is connected to, using the Settings database menu on the ORM control panel, ask support to license the new server properly, make sure that only one server in the cluster has the property hub equals true in the ORM bin bus server.props file. The server with this property will handle timer events. And finally, get new users to log in using the URL of the new server.